Good evening, everyone. So, kindly let me know in the chat if my voice is audible or not, guys. Okay. Thank you, Jashir. Guys, what about others? Let's wait for a couple of minutes and then we'll be starting today's session. So, do you people have any doubts um in the concepts which we have seen already? Yesterday, we have seen some of the basic concepts in Java. So, do you people have any doubts in yesterday's class? And also, I have asked you people to go through about how to represent a decimal number in its binary representation. So I hope you people have gone through. Yes or no, guys? Like, come on, how's the Josh? You can use any emojis, like, kind of thing, okay? And good evening, everyone who have joined. Guys, do you guys went through about the binary representation of numbers? So is it easy to understand, or can we have a small recap and then start with today's session? Guys, can you respond in the chat now? Jashir, have you went through binary representation concept? Thank you. That's cool. Okay, guys. So let's start. Okay. So today we are going to see, we are going to start our session with the concept called operators. Okay. So we know basically what is meant by the term operations, right? We are going to do some computation based on some inputs, and then we are going to yield a particular result. Okay. And in computer science, like we'll be dealing with solving any problems, right? So in order to solve any problem, we need some computations that is to be done, or some operations, some desired calculation that is going to be carried out. And in a statement, we'll be using variables, okay, which acts as a data here. So for example, in normal math, we'll be giving 3 plus 5, right? 3 plus 5 or 3 into 5 or something like that. Here, we'll be assigning 3 and 5 to the variables a and b respectively, and then we'll be giving something like a plus b. Okay, so whenever we are giving something like okay, so operators. So whenever we are giving, this is called a statement, okay? So C is equal to A plus B. This is known as a statement. And here, C, A, B, they are termed as operands. Operands in the sense, the data on which some operation is going to be performed, okay? And here, equal to and plus, they are known as operators. Okay, so we are going to see the operators which is available in Java. We do have 8 different types of operators, and for each operators we'll be also seeing some example programs as well. Okay, so don't worry. Here before that, in order to start with the computation, we'll be assigning some values to A and B. A is equal to 5, let's say, and B is equal to 3. Okay, so these are the data which is given. So C is equal to A plus B. So 5 plus 3, 8 will be stored in C. Okay. So here the thing which you have to remember from these things are, this is called a statement in a programming language, and here C, A, and B, the variables or the data that is on which some operation is going to be performed or calculated, it is called as operands. And the symbols, okay, the computation symbols which is used for calculating the operands or calculating some stuffs, they are known as operators. Okay, and in Java we do have 8 different types of operators, and they are: so arithmetic operators, unary operators, assignment, relational, logical, ternary, bitwise, and shift. So I asked you people to go through binary representation of numbers. In the sense, uh, let's see, when we are dealing it with binary bitwise and shift operators, binary representation. Binary representation in the sense, usually we write the code in high level language, right? So in terms of English, but computers can only understand binary. Binary means it is nothing but zeros and ones. Okay, whatever input we are giving or whatever thing, the computer will be able to understand only binary digits, which is 0 and 1. Okay, so if for example decimal number will be having the base value as 10. Okay, decimal number, the normal numbers which we used to call, for example 1 2 and 1 to anything 10, normal math, we do have numbers in mathematics, right? So that will be having the base value as 10, and that is normally termed as decimal number in terms of computer science. Okay, so for example, I'll be taking a decimal number 10, and I am going to represent this 10, the decimal number 10 with base value 10, in terms of zeros and ones. So the another name of zeros and ones is bits. So bitwise representation of this number. So we'll be seeing how we'll be representing. Okay. And another catch, what you have to know is you have to know unary operands. Okay. Unary operands in the sense, the operations or the computations which is being done on a single operand. Okay, operations carried out on a single operand. For example, A plus B. Here, A and B are operands. This is not unary. This is it contains 2 operands, right? So this is not unary. Okay. Whereas if you are going to do some computations like A plus plus or B minus or B minus minus or C plus plus, okay, or plus plus C, okay, so these are known as unary operators, okay, because here in your statement you are going to make use of only a single operand, and that is why it is known as unary. Unary means by definition it is single one. Binary means it is two. Okay. Yep. So here the operands, you are going to do the calculations on a single operand, and that's why it is termed as an unary operators. Okay. And yeah, we'll be seeing more on these things. So these are basically the 8 operators. And bitwise and shift, they will be dealing with the bitwise representation of decimal numbers. Okay. And first operator is the arithmetic operators. Arithmetic in the sense, they are the normal, very basic computations which we'll be doing in maths. It is addition, subtraction, multiplication, and division. Okay, the same thing. We are going to add 2 numbers and it will be yielding a result. And multiplication, same. The replicating of a particular number to this much number of times. Okay, minus, division. Okay, here another catch is the percentage symbol, or it is known as the modulus operator. A modulus operator, what it does is, actually modulus operator, it gives the remainder of a number. For example, if I'm giving 5 mod 3, so what will be the remainder when we divide 5 by 3? The remainder is 2, right? Remainder, it is 2, because in 5 we have only 1 3, and if that 3 goes, 2 is going to be our remainder. So 5 mod 3 will be yielding the result 2. 10 mod 5 will be yielding the result 0, because 10 is 10 is divisible by 5, so the remainder will be 0. So here the modulus operator, which is being represented in this symbol percentage, okay, so it is going to yield the remainder whenever we are dividing a by b. The remainder will be given by the modulus operator. Okay, so now people are clear with the operators, the arithmetic operator. Thank you, Vishesh. I'm fine, Vishesh. Thank you. I'm fine. How are you? And guys, have you people downloaded Java in your system? Or you can work with me parallelly as well. And for now, you can use online compiler, online Java compiler. Okay. So for first, I'll be giving an example of the arithmetic operators. Okay. You guys are clear with what is meant by an operator, and what is meant by an arithmetic operator, and what are the meaning of unary operators and operands? Are you people clear with this? Because when you take in a DSA question, you are supposed to perform many computations on it. So, and operators concept is basically simple, but still, if you people have any doubts, you can post it in the comments. Okay, so online compiler is taking much time. So oh, Bishesh, okay. So Bishesh, you are from previous batch, right? Same. I'm also glad to see you. Ma'am, I'm able to understand all the concepts of Java, but unable to write coding part. Can you suggest me best way to learn? For sure. Like, you can start. You can start your coding from solving very simple problems. Like, um, you can use coding platforms like Lead Code, HackerRank. Okay, and there you can use the tag easy level problems, and then you can start solving step by step. Don't worry, like for sure one day you'll be learning it. Okay. Okay, so demonstration of arithmetic operators. So let me use the scanner class in order to get the input from the user. Input java.util.scanner. And now I'll be creating a scanner object. Oh, inside the main method only we are supposed to create everything. Okay, and people, you can code with me parallelly. Okay, so that if you people have any doubts, or if you're getting any facing any kind of error, you can let me know in the chat. Okay. Yes, so and today we'll be solving a couple of DSA questions. Enter number 1 and int num1 is equal to sc.nextInt. Enter number 2 and int num2 is equal to sc.nextInt. Okay, and yeah, now I'm going to store it in a result variable a plus b. Okay, sorry, num1 plus num2, and I'm going to print the result. Addition int add. Okay, I'll be changing the variable name. So this is for addition, and multiplication, I guess you know, and this is for division, and this is for the modulus operator. For division, for modulus operator, num1 percentage modulo num2. Oh, it's not additional. It's division. And modulus. So I'm going to give num1 as 10 and num2 as 3. When we add, we are getting 13, and division it is 3, and remainder it is 1. Okay, so this is about the arithmetic operators. So people, do you have any doubts in arithmetic operators? Abhishek, like you can, I mean, seek the help from the team, because I'm not sure about the internship certificate. I'm just a lecturer here. So, guys, are you clear with? I mean, just people. I just want your acknowledgement if you are clear with the operators concept and the concepts which we have seen until now. No, ma'am. So you haven't understood Sanskari. Guys, if you people have any doubt, I can repeat it again as well. And arithmetic operators are quite simple. Guys, are you clear with the operators? I'm not sure, Bishesh. Like, you can ask the team. Guys, come on. Okay, sure. So, my class name is date. I mean, like, yeah, that's fine. So inside my class, I'm going to write a main method. Okay, and in order to get the input from the user, I'm going to use the scanner object, the scanner class. And the scanner class is available only in the util library of Java. So I'm going to import it by telling import java.util.scanner. Okay, and I have created a scanner object here, and these are the basic print statements. Okay, and I'm going to get a dynamic input from the user for num1, and I'm going to assign it to the variable num1. Okay, and next thing, I'm going to get another integer value, because arithmetic operators, it uses two operands. Okay, so that's why we are going to have two operands here. Num1 and num2 are the operands. Okay, and here num2 also I'm getting the input from the user, and in an integer variable add, I'm going to compute the addition of num1 and num2. So I'm using the plus operator, num1 plus num2, and I'm assigning it to add. Okay, and I'm printing it. And here, in order to yield the division result, I'm using the operator division operator, and I'm giving num1 divided by num2, and I'm storing it in division variable, and I'm printing the same. And modulus, we know modulo operator is actually used in order to retrieve the remainder. When we divide num1 by num2, then the remainder which we are getting. So that is actually uh, I mean, that's the result which will we be getting whenever we are using modulo operator, and then I'm going to print the remainder. So are you clear? Sure, Vishesh. Okay. So guys, what about Yashir, Simran, Sakshi? Are you people clear with this? Come on, yeah. Like, let me know in the chat. No. Okay. Thank you. Okay. So next we'll be seeing unary operators. Okay. In the unary operators, we are having two types of operators. One is plus plus and another one is minus minus. Okay, and um, In unary operators, we know we'll be using only a single operand. So here I'm using a. Okay. And here we are having the concept of post increment and pre increment. Okay. So whenever, first of all, whenever I'm giving a variable name plus plus, it is like I'm going to increment the value of the variable by one. For example, if a is equal to 5, then a plus plus means I'm going to increment the value of 5 plus 1. So now my a becomes 6. Okay. So a plus plus is same as a is equal to a plus 1. Just I'm going to increment the value that is present in that particular variable by 1. Okay. So we can also decrement a minus minus. If my a is 5 and I'm giving a minus minus, then my a becomes 4. Same. A is decremented by 1. Okay. And we do have post and pre. Post in the sense a plus plus, this is actually known as post increment, and plus plus a, it is known as pre increment. Okay. uh, in both of the post as well as in the pre increment, the a's value will be updated to 1. Okay, but you will be seeing the difference when we try to print the statement. Okay, I'll be telling you an example. And if I'm going to do something like a minus minus, then it is pre decrement, post decrement, and minus minus a, it is pre decrement. Okay, you'll be noticing the change. Okay, I hope you're clear with this. Enter num1. Okay, so I'm going to get an input from the user and I'm just going to print system num1 plus plus. Okay, so this is my post increment. So now my answer will be, I'm going to give 5 as my input and my answer is 5. So here you might be getting some question. Okay, what question? You said num1 plus plus actually increments the num value by 1, but when I try to print num1 plus plus, the same 5 is getting printed. Actually the value must be 6, right? So there could be a question for you people. Okay, here in this case, the num1 value is updated to 6, I mean updated by 1. Okay, now when I try to print the num1 here, out.println num1, when I try to retrieve my num1 value, see when I'm giving 6, 5 and 6. So the modification is being done. Num1 plus plus 5 plus plus 5, 6 is being assigned to num1. But the thing here is, in the print statement, first I'm printing my num1 and then only I'm going to increment it. And that's why the case is, we are getting the output as 5. Okay, carefully listen here. It is a catch over here. And if you people are going to attend the interview kind of things, and for sure you will be asked these kind of snippets involving the post increment and pre increment and all these things. Okay, so there could be MCQs which will be put forward to you in order to find the output of some, post increment or post decrement statements and expressions. So please um, pay more attention to this concept. Okay, so num1 plus plus, here the num1 value is modified, it is being updated, but in the println statement, first num1 will be printed and then only it will be getting incremented. Okay, but after this statement, num1 value will be incremented by 1, but here first num1 is being printed, that's why 5 is being printed, and next it gets added by 1. This is known as post increment. When you're seeing about pre increment, this is pre increment. Okay, here in this case, first the incrementation is being done. If I'm giving 5, then 6 is being incrementation is being done. So 1 is added to 5 and then only we are going to print the num1 value. So here the value will be 6. If I'm giving 5, then my output will be 6 because increment is carried out and then only we are going to print num1. Okay, and this is known as pre-increment and the same. This is post decrement. Post decrement. When I give 5, 5 is being printed because num1 is decremented by 1. But before decrementation, I'm going to print my num1 value. So that's why the same num1 is being printed. And when I give something like minus minus num1, then for sure 4 will be my answer because decrement is being done and then only we are going to print the result. Okay, and if I'm showing you, wait, interview questions based on post increment, post. Yes. So, like this, whenever you're going to attend the interviews, okay. So these kind of questions will be given, and they'll be asked to guess. They'll be asking you to guess what is the output. So questions like this, okay. So here everything that involves this pre-increment, post-increment, pre-decrement, and post-decrement concepts only. Okay, so please make use of this concept and be clear in this concept because here only many people will be making mistakes. Okay, so yep. So guys, are you clear with the unary operators? I hope everybody is clear with the unary operator. Then we'll be moving on to assignment operator. Okay, assignment operator, it is quite same. Already we have used assignment operator and here we'll be having equal to. Here here we'll also be giving s plus is equal to y. It is same as x is equal to x plus y, and x minus is equal to y. It is similar to x is equal to x minus y. Okay, uh, you can also give modulus, use modulus operator as well. So I'll be showing you an example of assignment operators. So I'm going to have two numbers. Okay, and in the int result I'm going to give int result. I'm going to declare result. Okay, num1 plus is equal to num2, and this is same as num1 is equal to num1 plus num2. Okay, and when I try to print the num1, when I try to print num1, I'm giving two values 3 and 5. My num1 will be 8. Okay, because num1 is equal to num1 plus num2. Num1 and num2 is being calculated and then it is being assigned to num1. And one more thing, whenever you are giving something like this, num1 is equal to num1 plus num2. Okay, first this thing is calculated and the value which is present in the right side will be assigned to the variable which is present in the left side. Every time the cycle goes like this only. Okay, so never it comes like in this way, like this only. Okay, so in the right side, whatever value it is being computed or whatever value you are giving here, it will be only assigned to the variable over here. Okay, and yep, the same things only. A minus, I mean replication, star means multiplication, the same thing only. So I have shown you an example for addition, and in similar way only all other things is going to work. So I think we cannot waste more time on that. Yes, next thing is relation operator. Okay, so relation operator, actually the the output of the relation operators is going to be a boolean value, which means true or false. For example, here we'll be having symbols like less than, greater than or equal to, less than or equal to, not equal to, and double equal to. In the sense both are equal or not. Okay. So here the result is going to be true or false. For example, if I'm going to ask if 5 is greater than 3, the answer will be true. If I'm going to ask 5 is less than 3, it is going to be false. Okay. So relational operators is actually used in order to yield the relation between two operands. Okay, we are going to check and compare two operands, whether one is greater than or equal to the another one, or one is lesser than or equal to another one, and always the output of the relation operator is actually going to be a boolean value. Okay, so now we'll be seeing relational operators example. Again, I'm going to here also will be using two operands, because for comparison we need two things to compare, right? So yes, in a boolean variable, I'm going to just assign num1 greater than num2. I'm going to print the result. Okay, so I'm giving num1 as 5 and num2 as 3. The output will be true because 5 is greater than 3, right? If I'm giving 5 is greater than, num1 greater than or equal to num2, in the sense it checks for both greater as well as equal to. Okay, I'm giving num1 as 5 and num2 as also 5. It gives true because it checks whether num1 is greater than or equal to num2. Either num1 can be greater than num2 or num1 can be equal to num2. Okay, and this is also a statement. Okay, so please don't get confused when like this two equal to sign is given in a statement. First this is being computed and then it is being assigned to the variable boolean variable result. Okay, uh yep, so you can, for not equal to, you can use an exclamatory symbol and equal to, which denotes not equal to. If I'm giving 5 and 5, 5 is equal to 5, right? But I'm checking whether 5 is not equal to 5, so the output will be false. So this is how relational operator works, and we haven't went through double equal to, the same. Like I hope you people are able to understand. Okay, if you have any doubts, just post in the chat section. After completing certain concepts, I'll be coming and I'll be clearing your doubts. Okay, and next thing, logical. Okay, uh, in logical also, the output is going to be a boolean value only. Okay, but in terms of logical, you have to know something called as the truth table. Okay, truth table in the sense whenever you are because here we are using and or not, logical and logical or logical not. Okay, you have to be very clear whenever you are saying and or not, because in bitwise operators also we do have things like and or not. Okay, um, in logical operators as well we do have and or not. So we'll be first seeing the concept, what happens if it is a logical and. Okay, and people, I don't know how many people know what do you mean by a truth table. Okay, uh, I mean, for easier understanding, okay, assume and operator as multiplication. Okay, assume and operator as multiplication. Okay, and for understanding, just for understanding, keep um, 0 as false and 1 as true. Okay, so I mean, we are going to compare um, two expressions. Okay, and we have to, I mean, see here in the example, this is a relational expression. A is less than 10, it is a relational expression, as well as A is less than 20, it is also a relational expression. Okay, here A is less than 10, it gives some boolean value as the result, and this also gives the boolean value as the result. The boolean value can either be true or false. Okay, so we are going to compare the boolean values only here when it comes to logical operators. Okay, so that's why I'm asking you for understanding. You assume 0 as false and 1 as true. Okay, so when you apply, I mean, there will be four combinations, right? Either true, either your statement 1 yields true and your statement 2 also yields true, or the expression. Either your statement expression 1 can yield result true, but your expression 2 can give false as the output, or your expression 1 can give false as the output, and your expression 2 can yield you a true as the output. Okay, and the next case is both can give you a false. Okay, for example, if you are not able to understand this, for example, like let me tell you an expression. 4 is less than 10, and logical and 3 is greater than 5. Okay, so here 4 is less than 10, it is 4 is greater than 10, it is false, right? And 3 is greater than 5, it is true, so it comes under this condition. Okay, or for example, you're giving 4 is greater than 2 and 7 is greater than 9. So here 4 is greater than true, it's true, and 7 is greater than 9, it is false. It comes in this case. Okay, so only 4 combinations will be possible. So these are the possible combinations. Whenever you are computing this type of statements, okay, this type of expression, okay, we are going to check what will be the output, false and true. Either it will be false or true. Okay, so assume it as 1 and 1, or 1 into 1. Okay, here 1, I asked you to keep false as 0. 1 into 0, 0 into 1, 0 into 0. So anything multiplied by 0 is 0, right? So here also 0 will be the answer, 0 will be the answer, and 0 will be the answer. Okay, so which means 0 represents false, 0 represents false. 1, oh sorry, 1 into 1, it is 1. So 1, so when both my expression is true, whenever I'm applying logical and to both of the expression which is giving me true, so my output will be true. So in this case my output will be false and true, false and true. The output will be a false, right? So my output will be false. Okay, in this case, true and false, true and false, my output is going to be false. So false. So this is how logical and works, and this is the truth table. Okay, I'll be showing you truth table of logical and. Yes, so this is going to be my truth table for my and. 0 and 0 is 0, both are false means false. I mean, you can keep it something like this. So if any of the expression yields false as the output, then the final output will be false. So guys, are you able to understand logical and 3 is not greater than 5? Yes. Oh, sorry. uh False and false, the output will be false. Thank you. Thank you, Mahesh. Okay. let me go with online compiler. Okay, so guys, have you understood the logical and concept and the logical and truth table? Are you people clear with how the logical operators work? I mean logical and work. You can let me know in the chat if I want to repeat it again or not. Okay, thank you, Shubham. Okay, so this is about logical and, okay, and when you consider logical or, you'll be using a pipe symbol. This is known as the pipe symbol, logical or. So it will be quite opposite to logical and, okay. Okay, it will be quite opposite. Okay, if either of your expression yields true, then the output will be true. For example, here true and true, so the output will be true. Here true and false. Your first expression yields true, so your control, it never goes and checks the second condition. Automatically, the final result will be true. Okay, and false. It will be evaluating the first expression. If it is false, then it checks the another condition, and if it yields true, means the final output will be true. Okay, only when both the condition yields false, the result is going to be false. Okay, for example, here let's have 14 is greater than 10 and 3 is greater than 5. Okay, here my control comes and checks this expression. If 14 is greater than 10, so my output will be true. It never goes and checks 3 is greater than 5. Already my first expression yields true. So whatever is going to be my second expression, my output is going to be true. Okay. If it is true also, that's the last final output will be true. If it is false also, my last final output will be equal to true. So it never checks for the second condition when my first yields true. Okay. So it directly goes and tells us the answer, it is true. Okay, and in this condition 4 is greater than 2, it is 4 is less than or less than 2, it is false, and 7 is greater than 9, it is also false. As both the condition is false, the final output is false. And one more thing, 4 is less than 2, it is false, right? Now only my pointer goes and checks the second expression. If it is true, then my output will be true. If it is false, and my output will be false. Okay, so this is about logical or. So truth table of logical or. This is my truth table of logical or. Okay, uh no, wait, no, not this. Mm. This is my truth table of logical or. Only when both my input A and input B is false, my OR operator will be giving a false as my answer. If either one is true, then true will be my answer. Okay, so this is all about logical OR. And logical AND is quite simple. Okay, and in logical AND we'll be just using a single operand. Okay, I mean it is not single operand. Logical AND, logical logical not. The symbol for representing logical not is exclamatory symbol. Okay, it's very simple. Not of true will be false. It is something like the complementary. Okay, like opposite to true is false, so not of false, opposite to false will be true. It is going to be my answer. Okay, so yep, I'll be using online company. Okay, so let my first expression be Boolean expression 1 is equal to 4 is greater than 9, and Boolean expression 2 is equal to 5 is greater than 10. Okay, so logical and expression 1 and expression 2. I'm giving everything in println statement itself. Okay, logical or expression 1 pipe symbol like logical or, and another thing is logical not. So I'm going to perform and operation, and then I'm going to apply my not operator. Okay. Okay. So here my first condition is false, and my second condition is also false. So false and false, false, false or false, false. False and false is false. Not of false is true. If I'm giving 4 is less than 9, okay, let's see what happens. True and a false expression. Now my logical AND gives false, because in my logical AND in the truth table, if any one of the expression yields false, the output is going to be false. So here my expression 2 yields the result false, and that's why my last final output will be false. But in or it is quite opposite. Either one of the expression yields true also, my final output is going to be true. So here my first expression is true, and that's why the output is true. And not is something the the opposite. Okay, something like the topsy turvy. So expression 1 and expression 2 yields false as the output, not of false is true. And this is all about the logical operators. Guys, are you clear with the logical operators? If you people have any doubt in the logical operators, you can let me know, because only if you are clear with the logical and or not operations, whenever we are dealing with the bitwise operators, no, it will be easy for you to understand, because in bitwise also we do have bitwise and bitwise or and bitwise not. Okay, but the thing here is now we are applying the operators on expressions, right? There we'll be applying the same and logic or logic in terms of bits. For the bits we'll be applying like for the bits we'll be applying the logical operators. Okay, cool. And next thing here, it is a very very special operator. Okay, ternary operator. Okay, and another name of ternary operator is conditional operator, or you can also call it as something called a decision operator. Okay, and this will be my syntax of using a ternary operator. And guys, uh, like trust me, like if you want to reduce the number of lines of code whenever you are dealing with the coding DSA part, ternary operators helps you a lot, because uh if else statement, like I don't know how many people know conditional statements in Java. Like we do have if and else, so we can simply it is very easy to write a logic which has been written in if else in ternary operator. We can write it very easily. Okay, it is in single line itself we can complete a lot many work. And also in order to print a value. In print statements also we can use ternary operator, okay, and the syntax or the structure goes like this, okay. Some condition will be given here, okay, and if this condition is true, then the expression which is present over here will be getting executed. If this condition is false, then the expression which is here will be getting executed, okay. And we'll be using a question mark and a colon, okay. Question mark is actually, it represents whether this condition is true or false. If it is true, then expression 1 will be getting executed. If it is false, it is the expression 2 will be getting executed. The purpose of calling it as a conditional operator is based on the condition only, based on the true or false result of this condition only. The further steps will be calculated, okay. So let's see the demonstration of ternary operators. Okay. Okay. So I'll be taking you a use case, okay. I'm going to check which is greater, which number is greater. So I'm going to take two numbers as input from the user, okay, and then I'm going to check which number is greater, okay, with the help of ternary operator. The same whatever logic you're applying using ternary operator, you can also do it with the help of if-else statement. Don't worry, next we'll be seeing only if-else statement, okay. So in my ternary operator, I'm going to okay, tell okay. So boolean result or boolean okay, result is equal to, if my num1 is greater than num2, okay, then I'm going to int greater number. If my num1 is greater than num2, then I'm going to call my num1 as my greater number, or else I'm going to call num2 as my greater number, okay. So if this condition is true, if num1 is greater than num2, then num1 will be getting assigned to greater number, okay. If this condition is false, then num2 will be getting assigned to greater number. Now I'll be printing the greater number is greater number, okay. So now my num1 will be 10 and next number will be 56. The greater number is 56, so here you have to give a space, okay. My num1 will be 35 and my num2 will be 27. The greater number is 35, okay. So this is how we'll be able to use ternary operator. So based on the condition, we'll be checking whether which number is greater. So if num1 is greater than num2, here we have used relational operator. If this condition is true, then greater number will be having the value num1. If this is false, then it means obviously number 2 will be my greater number. So in the variable greater number, I'm going to assign num2. So guys, are you clear with the ternary operator? Packages in the sense usually whatever class files you are writing, it will be like enclosed in a package only. So package is collection of classes, or collection of classes is actually termed as packages, okay. So in packages you will be having a set of Java files or a set of Java code or a set of Java classes. It is being termed as packages. So there are many predefined packages as well. And whenever you are using Eclipse, normally for creating a class, you are supposed to follow the hierarchy. First, you have to create a package, and in that package only you will be writing the classes. So for example, you see here, um, here LLD preparation is my package name. Okay, so when I view this file, package name is LLD preparation, and these are all my class files. So collection of class files is known as packages. So inside my package LLD preparation, I'm having a set of class files. Okay. Okay. So only Jashir is active today. What about others? Shweta, Mahesh, Shubham. Only four are active. So guys, are you clear with the concept? Are you clear with the concept of ternary operators? Because ternary operator is very an interesting and a special operator kind of thing. And Mahesh, are you clear with the meaning of packages? Okay, thank you, Simran. Thank you. Okay, okay, guys, cool. So here next we come for the bitwise and the shift operators. Okay, so guys, do you people need recap for the binary representation of numbers, or already you know the concept? If you need a small recap, then let's see how to represent a decimal number in terms of bits, zeros and ones, and then I'll be telling you how actually the operators work. So do you need a recap? I mean, do you want me to tell the concept, or have you people seen it already? So if you people know it already, then directly we'll be seeing about the bitwise and the shift operators, or else I'll be teaching you the concept and then I'll be moving on. Guys, do you want me to repeat the concept? I mean, do you want me to teach the concept of binary representation? Because yesterday I asked you people to learn and come. I mean, anybody can answer, because Jashir, Shubham, Simran, they want they want me to teach binary representation, or you people know already? So you know already. Okay, they want me to do it, teach. Okay, okay. So I mean, bear with my handwriting. So usually, like I have said, decimal number means we'll be having the base value as 10. For example, I'll take my decimal number as 8. Okay, so usually it will be having my base value as 10. I'm going to convert my decimal number. I'm going to represent it in terms of binary, and the base value of binary is 2. Why it is 2? Because I'm having only two digits when it comes to binary, it is 0 and 1. Why it is 10 over here? Because in the decimal representation we have only the digits from 0 to 9. 0 to 9, right? 0, 1, 2, 3, 0 to 9. Okay, now um, as it is a binary number with the base value 2, the representation will be done only, like the bitwise. It is like 84212. Like you are going to arrange the bits only in the powers of 2, because it is binary, right? So first let's write 2 power 0, 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, up to 2 power n. Up to 2 power n. And then if we compute the thing, it is a for 1, 2, 4, 8, 16, because 2 power 4 is 16, right? 2 power 5 is 32, and it goes on. Okay, now in order to represent 8, okay, you have to see for the places, like I mean, in such a way, like if you're having 8 already here, against 8 you want to put 1, and then you want in the remaining places you want to put 0, and this is the binary representation of 8. Okay. For example, you want to represent 10. Okay, let's take you want to represent 10. You have to mark 1 and corresponding to the digits, by adding which you'll be getting 10. So here you'll be getting 10 when you add 8 plus 2, right? So you put 1 in 8 and the 2 places, and in the remaining places you put 0, and this is the binary representation. Okay, so if your decimal number is 7, then you have to see by adding what and all the things you'll be yielding 7. So 4 plus 2 plus 1 is 7, right? So you have to place 1 in the corresponding places, 4, 2 and 1, and in the remaining places you have to put 0. And this is how you will be converting a decimal number to its binary format. So people, are you clear with this? Are you clear with how to represent decimal to binary? Just it is very simple. Okay, so these are your binary numbers. Okay, these are your binary numbers. Sorry, these are your decimal numbers. Okay, and whenever you want to represent in binary, you have to see by adding what and all the digits you are getting 8. So already 8 is present. So in that corresponding place position, just put 1, and remaining all places you put 0. And when it is 7, okay, when you add 4 plus 2 plus 1 only, your output will be 7. So just put 1 and then remaining bits as 0. Guys, are you clear with the binary representation of decimal numbers concept? Because then only I'll be telling you how to apply and or not here. And also we'll be seeing the shift operators as well. And in order to understand the shift operators also, you people want to know about the like bitwise representation. Are you people clear? Okay, thank you, Mahesh. Okay, so now I'm going to represent in terms of 8 bits. Okay, so 8 bits in the sense 1 2 3 4 5 6. So 2 power 6 will be my 7th bit, and 2 power 8 is going to be my 2 power 6, 2 power 7, okay, until 2 power n. Okay, so 32, then 64, then 128. This is 8-bit representation. Okay, 8 bits are there, right? Now I'm going to first tell you how and works, bitwise and. In logical, we do have two ampersand symbol, but in bitwise and we'll be having only a single mm, ampersand symbol. Okay, so 5. Let my num1 a be 5. Okay, 5 representation. 4 plus 1 5. So remaining places I'll be marking as 0. And b is going to be 3. Okay, and I'll be having 2 plus 1 is 3. So remaining place is 0. Okay, now I'm going to compute a bitwise and b. Just the same truth table, but the thing here is we are going to apply and logic bitwise. So false and true and true, true and true, 1 and 1 is 1, 0 into 1 0. So I asked you people to assume and operation as a multiplication, and 1 as true and 0 as false, right? So 1 into 0 0, so everything is 0. Okay, so now I want to take the decimal representation of this binary. So here, if you see, we have only 1 in the ones place. So A and B, 5 bitwise and 3, my output will be 1. Okay, so I'll be telling you in the coding wise. Thank you. Thank you, Shir. Okay, so let's see of bitwise operators. Okay, num1 and num2. Okay, now what I'm going to do is, and num1 num2 int result is equal to num1 and num2. So I'm going to print the bitwise and is result. So I'm going to give here we are given num1 as 5 and num2 as 3. My bitwise and is 1. Okay, because here they are going to apply the AND operator in the bits. So in bits level we are going to apply corresponding bits. So 1 and 1, okay, 1 and 1, 0 and 1, 1 and 0. Okay, so people, do you understand how bitwise AND works? And similarly for guys, do you understand how bitwise AND works? Waiting for your reply. Because if you're clear with this only, then OR will be very simple. OR also the same thing. They're just going to apply the truth table to the corresponding bits. That's it. Thank you, Shubham. Okay. So, oh, sorry. Okay. So, next we are going to see bitwise OR. So, for bitwise OR, in logical AND, we used pipe symbol, right? We used this symbol. But in bitwise, we'll be using only a single I mean, I don't know, like the symbol name, like we'll be using like this A bitwise B. Okay, single pipe, and it's not pipe. Okay, so we know the truth table. When it comes to OR, okay, if any of the operand is true, or if any of the operand is 1, the output is going to be 1, right? So here 1 and 1 already it is 1, so 1 will be my output, and 0 and 1. So one of my operator is true, so obviously my output will be true. 1 and 0. So one of my operand is already true, so my end result will be true. Then everything is 0 here, so 0. So when you convert this binary representation to its decimal format, you just have to add the places where 1 is there. So 4 plus 2 plus 1, 7. So when I give 5 bitwise or 3, 7 is going to be my answer. Okay. Now let me show you in the coding part. 5 bitwise or bitwise or, okay. 5, 3. 7 is going to be my output. So this is all about bitwise operators. Okay. Guys, are you clear with the bitwise operators? So next we'll be seeing the shift operators. Okay. Shift operators means we are going to shift the bits. We are going to shift the bits of a number to a specific number of times. Okay, for example, I'm giving 10. I mean, this is known as right shift, and this is known as left shift. Okay, if I'm giving 10, right shift 2, which means bits of 10 is going to be shifted towards right. Okay, how many times? 2 times, because here we are giving 2, right? So 10, right shift 2 means we are going to shift the bits of 10, or the binary representation of 10, the bits that is present whenever we are representing 10, we are going to shift it towards the right. How many number of times? 2 times. If I'm giving 5 here, means I'm going to shift the bits of 10 towards its right 5 times. Okay, similarly, if I'm giving 8 or 8, left shift 2 means, or 3 means, I'm going to shift the bits of 8 to its left. How many times? 3 times. Okay, and this is how a shift operator works. I'll be showing you an example. Okay, so let's say 10 left shift 2 and 8, sorry, 10 right shift 2 and 8 left shift 2. Okay, guys, I hope you're clear with the bitwise operators. Okay, and in bitwise we have one more operator, XOR operator. I'll teach you. Okay, so shift operators, right? um hmm. 10 right shift 2, right? So 10, how we'll be representing 10? Just add and put the places where it sums up to 10. 8 plus 2 is 10. So in the places of 8 and 2, just put 1 1, and then like in all other places put 0. Now uh 10 right shift 2. Okay, right shift in the sense we are going to shift the bits to this side. Okay, now shift all the bits to right side. Okay, so this 0 goes somewhere outside, 1 comes here, 0 comes here, 1 comes here, all the bits will be getting shifted. 0 here, 0 to this place, this 0 comes to the previous place, this 0 comes here, and append 0 here. Okay, I asked my system to shift 2 times. Here I have shifted, this is my first shift, right? Only one time I have shifted. So one more time I want to shift. So shift, this 1 goes outside, this 0 comes here, this 1 comes here, this 0 comes here, this 0 is shifted over here, and all the zeros is shifted over here. This 0 is shifted over here, and at the last append 0. Okay, now 10 right shift 2, right? So first time I have shifted, and this is my second shift, and that's it. I have asked my system only to shift 2 times. So now what is going to be my decimal value of this? So I have 1 only at the 2 second place, so my output will be 2. So 10 right shift 2 will be 2 is my answer. So let's see in the coding part. Okay. Shift operators. In result, num1. Oh no, wait. I'll comment it out. Okay. Or else I'll comment everything. Wait. Shift right. So 10, right shift 2. 2 is my answer. Okay, because here also we have got the same output, right? So here 2. After shifting the bits of 10 to its right 2 times, okay, we'll be getting 2 as the output. And for a single shift, you are just, you want to shift only one place. So in my first shift, I have shifted it to the next place. And my second shift, I'm shifting it towards the right. Okay. So this is how the shift right works. Guys, are you clear? Are you clear with the shift right operator? Next, let's see the shift left. Shift left is obviously, the vice versa of shift right. I mean, shift left is vice versa of shift right. So, guys, are you clear with the shift right concept? And this is how your shift operators works. That's why I have asked you to, learn by representation, because both bitwise and shift, these both operators, actually the computations are done in the bitwise level, in the bit level. Okay. So, guys, are you clear with the shift right concept? Waiting for your reply. If you're not that much clear, once we see the shift left, for sure you will be getting clear of the concept. Okay, thank you, Shiva. Okay, so okay, so next, in the shift left, 2 times 8, left shift 2, right? So 8, how will be representing? 8 is already present, so 1, eh, and in every other place it is 0. Okay, so you're going to shift the bits to towards your left. Okay. Okay, so you're going to shift this here. So 0 comes here. Shift left 0. Uh, per shift you want to shift only like 1 bit. Okay, in the sense you cannot shift this 1 to like this, or you cannot shift the 1 to like this. Okay, so oh sorry, 1, this 0 comes here, this 0 comes here, this 0 comes here, and at the last one spaces will be there, you have to append 0. Okay, and in my next shift, this is my first shift, got over. In my second shift, this 0 comes here, this 0 comes here, this 0 comes here, this 0 comes here, 1 comes here, 0 comes here, this 0 comes here, and this 0 goes to the next bit. It goes outside, and at last you'll be appending a bit. Okay, so yes, 8, left shift 2. You have to compute the result over here. 1 is present only at one place and it is placed at the value 32. So 32 will be my answer. Let's check. Yes, you are correct, Jashir. And repeat once more. Yeah, left sheet. Now are you clear, Jashir? And like great claps for Jashir because you have tried solving. I hope everybody is solving as well. 8. I mean, yeah, this is the binary representation, but the output will be a decimal value only. Okay. So shift left. 32 will be my answer. Good, Jashir. Okay. 32 will be my answer. So, guys, are you clear with the shift operators? We do have two types of operators, shift left and shift right. And also, uh, in the way how, the post increment and pre increment operators is very important. Shift left and shift right is also very important because interview question based on shift operators in Java. I mean, post. Okay, so these kind of snippets will be, this is not a snippet, code snippet in the sense, snippet meaning a part of the code. So like this snippets will be given to you and you are supposed to answer, okay? So guys, are you clear with the shift operators? Now it's time for us to see one of the bitwise operator and we'll be solving a very interesting question. Like we can use the bitwise operator in order to solve a DSA question. So I'll be telling you that approach. Okay. So just I want to know, are you people very interested to see, today the logic, how to use a bitwise logic in DSA? Like how's the Josh? Are you people eager to learn something today about DSA? Okay. Now, um, the concept which we are going to see is bitwise XOR. Okay. Or it is exclusive or. Okay. And it is actually represented by this symbol A, A bitwise, I mean XOR A XOR B. Okay. Now, the truth table of XOR is if both the operands are different, then my output will be true. True or sorry, true XOR true. False XOR false. True, true, false, false. So both are same, right? My first expression also gives true, my second expression also gives true. So when I apply XOR, it is going to be false. The output will be false. In the sense, if both the operands are different, then the final result will be true. For example, if this is the case, true XOR false, then my output will be true. False XOR true, then my output will be true. Okay. Uh, XOR XOR get truth table. Yes. See here. If both my operands is same, then my output will be 0. Here 0, 0, both the operand is same. False, false, so it is false. Here 1 and 0 is different, so my output will be 1, true. Here 0 and 1 both are different, so my output will be true. Here 1 and 1, A and B is same, so my output will be, final output will be false, okay? Okay. Same, similar to that thing only. Okay. I'm going to check 8 XOR 2. Represent 8, 0, 0, 0, 0, 1, 0, 0, 0. Let's suppose say 12, okay? And when I represent 12, my output will, my binary representation will be 8 plus 4 is 12, remaining all 0. So when I compute this, okay, 0 and 0 both are same. So my output will be 0, because here the truth table 0 and 0 is 0. 0 and 0 again 0. 0 and 1 it is 1. 1 and 1 it is 0. So 0, 0, 0 and 0. So here my output, my result will be 4. So 8 XOR 12, my output will be 4, because 1 is present only in the 4th place. Okay. 8 XOR 12. Bitwise XOR. Okay. Bitwise XOR, it is 12. Here also we got the result. I mean, sorry. 8 XOR 12, the bitwise XOR is 4. Here also we have got the result 4. So guys, are you clear with the bitwise operators and the shift operators? Okay. So before getting into, so this is all about the operators, okay? And next thing which we are supposed to see is the conditional statements, okay? Before getting into the conditional statements, we'll be seeing a very, very interesting, I mean, it is a very basic question, okay? It is a very simple question, but I just want you people to come up with your own logics, okay? The question is very simple, okay? Don't worry, the question is very simple, but I want you people to, like, listen, like, come up with your own logics, okay? So I'll be telling you the question now, okay? And now you people, like, you respond in the chat, like, what and all the methods. If it's wrong, right, doesn't matter. Only participation matters, okay? So, okay, the question is, no, okay. Mm, I mean, for this we need the concept of array, okay? But okay, I'm going to have an array, okay? Array in the sense a linear data structure where like I'll be like storing the elements which is of same data type, okay? So I'm going to have an integer array, and in my integer array I'm going to have some amount of numbers, okay? Okay, I'll be having the frequency of numbers, right? For example, 1 3 3 1. So here the frequency of 1 is 2, and my frequency of 3 is 2, because 1 is present 2 times and 3 is present 2 times. So this is known as frequency. The count of a particular element is called as frequency, right? So yes, so I'm going to have numbers inside my array. One note here is I'm going to have the except a single element, I'm going to have all the other frequency of the elements as even. For example, here in this case, frequency of 1 is 2, frequency of 3 is 3, frequency of 5 is 4, right? So all all the elements count will be even except one number. You have to find that one number. For example, here my frequency of 1 is 2, it is an even number. My frequency of 5, it is also an even number, but a single element exists, 3, which has odd frequency. So I want to check which element has odd frequency. Okay, I think you people are getting what I'm trying to say. In the sense, I'm going to have an array of elements, okay, where every element has frequency, has an even frequency, okay, except one element. That one particular element will be having odd frequency. It can be 3 or it can be 5 or it can be 7, anything. I just want to spot that number which has odd frequency. Only one number, only a single number will be there with odd frequency. All other numbers will be having an even frequency. So I just want like to highlight that particular element which have odd frequency. How can you do this? I mean, like, you can tell me the brute force approach. Brute force in the sense, a very naive approach. Okay, you're going to have a set of elements in an array. Every element will be having even frequency except one element that has odd frequency. Okay, odd count. So I want to spot that number. Guys, come on, like, you can tell me your logic of how to solve this particular problem, like, in the chat. Don't worry, even it's wrong also, that's completely fine. So I just want you people to know, like, because we have seen an operator, okay, with which we can solve this question very simply, but that is an optimal approach. Okay, you can also give it by using brute force approaches as well. So come up with different logics and you can reply in the chat. Jashir, Madhuvin, Shubham, come on guys. Even if it's wrong, that's fine. Mahesh, Shweta, we need to do first declare frequencies of every number. Okay. So the input is only the array. No. We need to do first declare frequencies of every number. Only the array is given to you. Only the array is given to you. You have to compute the frequency. Oh, so you are saying, like, first we have to compute the frequency, and then we have to, check if it is an odd or even frequency. So am I right, Jashir? So you're telling me we have to first count the number of frequencies of every element, and if the frequencies, we have to check if it's odd or even. If it's odd, then we have to print that particular element. Use a loop to check the even and odd conditions, and divide and conquer strategy maybe. Okay, I'm happy, like, two people have come up with some logic. Okay, any other logics, guys? May use conditional statements. Okay, cool. Got it. I thought we need to do it manually. No. Like, only array is given to you. The thing here is you have to spot out the element that have odd frequency. And divide and conquer strategy and all, those are very like advanced concepts in DSA. But that's fine, like, out of box thinking, right? Guys, what about others? Shweta, Shubham? So I hope many people are finding answers of how to solve this particular problem, right? Today we'll be seeing the concept of how to solve the problem. Okay, Just I'll be telling you how it works whenever DAC, divide and conquer. Uh, divide and conquer, it works. But like it works. Like, don't go to that much advanced things. Like, just very basic. Like, it is something like uh we'll be using, we'll be finding. Okay, guys. So come on, like, if you want to browse the internet, also you can. So what and all? I mean, just check what and all the different ways to find frequency of an element in an array. In Java, we have a collection framework for that as well. Okay, in order to find the frequency of an array. I mean, frequency of elements in an array or frequency of elements in an array list, anything. So, it has been said that we have to find the frequency and then we have to compute if it's odd or even. Yeah, perfect. That's one of the method. But how to find frequency of the elements that is present in an array? We do have a default collection in Java. Anybody can come out with the answer. Like, you can browse any LLMs you want, or you can browse the internet and check, because here it is not like, it is something exploring and learning. And anyways, I know the answer. Like, so guys, are you working on it? So I'll be giving a couple of minutes for you. So or else, like, I'll explain how to solve this particular problem, and then yeah, I'll code it as well. But don't worry, okay. I'll be using array as it is given as an input. Okay. But arrays we'll be seeing tomorrow as well. We can use a loop, okay. Then we can traverse an array. Then maybe we can. Okay, sure. Yeah, that's cool. That's a naive approach. Okay, great. Guys, anyone? Anyone wants to try? So I'll be waiting for a couple of minutes. Like, just check what is the collection framework in Java which we use basically to find the frequency of elements in an array, or frequency of elements. Okay. So um, one of the approach to calculate the frequency of elements is one of the approach. Okay, by using hash map. Okay, hash map is one of the collection framework in Java. In hash map, the elements are stored in terms of key value pairs. Okay, so like this, it will be stored. Key must be unique. Okay, so by using hash map, like, I can do something like one frequency of one will be 2. This is key and this is value. Keys must be unique in a hash map. People who know Python, hash map is similar to hash map works as same as dictionaries in Python. Okay, so one is the key. Key value pair is separated by a colon. Okay, and 2 is the frequency. Then 3 is my key. Then 3 will be my frequency, and 5 is my key, and 4 will be my frequency, and then like I can iterate over the hash map and check if my value is odd or even. Okay, this is one of the method. Okay, yeah, you are correct, Mahesh. Okay, hash map which is used in data structure. Okay, and one more thing. The I mean we have seen something called as, guys, are you people very eager to know the logic? It is a very very simple logic only, like I'll be telling you, it will be quite interesting. Okay, don't shout me for giving me this much hype, but once I reveal the logic you'll be quite surprised. Okay, so okay, we have seen, so here the question is, we have to find the element, hmm? We have to find the element which has odd frequency, right? So one of the method is using hash map, and the next very simple method which we have seen now, we can use bitwise XOR. Okay, for finding the element with odd frequency. Only in if the question is in this scenario or in this case, we can use bitwise XOR. Okay, for example, okay, we know hash map is DSA part. Yes, hash map function. Through this hash function, every data is converted into unique. I mean, and don't go that much, like that much deep. Yeah, hash map. Yeah, the reason behind how we are storing hash map is like this only. But in Java, we used to code in a different way. Okay, so yes, okay. What is 8 XOR 8? 8 XOR 8. 8. 8 XOR 8. Same, right? 0. I mean, whenever I try to represent it in binary format, 0 0 0 0 1, right? Okay. So when I try to apply XOR, in XOR, what is our truth table? Only if both the operands are, having these different, different values. Like if my inputs both are different, then my output will be true, or else it will be false, right? So it is same 0. It is also same, so 0. It is also same, so 0. 1 is also same, 0 0 0 0 0. Okay, now what happens when we give a number n the same number XOR? It cancels out, right? It is the output 0. Am I right? So in our case, what was our array? It was 1 3 3 5 5 1 3 5 5, right? 3 5 5. So what happens? Whenever I'm applying bitwise XOR for all the elements which is present in the array, all the even elements will cancel out. 1 and 1. 1 XOR 1 is 0. It cancels out. 3 XOR 3 cancels out. 5 XOR 5 cancels out. 5 XOR 5 cancels out. So everything is 0. Okay. So 0 0 XOR 3. The output will be 3. And we are getting the element which is of odd frequency. That's it. So I'll be telling the coding part. Okay, so it is finding the element with odd frequency. Guys, have you got the logic of how to work? What happens now if the key value of both the frequencies are same? Keys must be unique. Okay, keys must be unique every time. Key value, okay, key value must be unique. Key value of both the frequencies are same. Key value must be unique, Jashir, okay, every time. It won't allow duplication of keys in hash now. Okay, so I am going to give an input array. Int, don't worry, tomorrow we'll be seeing about Java, I mean arrays in Java, don't worry. Int is equal to, I'm giving same input. Guys, are you clear with the logic? Okay, now, okay, int result is equal to 0 for int. Don't worry, we haven't seen the for loops as well. Okay, for int I is equal to 0, I is less than a dot len minus 1 I plus plus result XOR result is equal to I XOR a of I XOR a of I plus 1. Once again, this result. Okay, the element with odd frequency. Okay, guys. So I'm giving an input array. Okay, it is 133551355, and my result is actually I'm initializing it to 0. Okay, and loops also we'll be learning tomorrow. Don't worry. And with the help of a for loop, I'm just going to apply bitwise XOR for each and every element in my array. Okay, and after applying, when I try to print the result variable, the element with odd frequency will be coming. Let's suppose I'll be changing the value as well. So I'm adding a 3 and 7. Okay, so here in my case, 7 is my odd frequency, so 7 must be my answer, right? When I run, the element with odd frequency is 7. Okay, no matter if you're placing 7 anywhere in between, also 7 will be the correct answer, because when you apply XOR, the equal elements, because I have already said only a single element will be having an odd frequency, and all other elements will be having an even frequency, right? So all the elements with the even frequency will be cancelled out. Okay, so this is a use of bitwise XOR operator when it comes to solving a DSA question. Guys, are you clear with the code, with the solution for this problem? Don't worry how to represent array and all. So just I'm telling you, I'm giving you a logic of how to apply a bitwise XOR, and also bitwise and please don't underestimate the power of bitwise operators, because bitwise operators plays a very 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 important role when it comes to competitive programming, because there could be many problems like longest common subsequences and questions like this. Bitwise operators are used. Okay, let's bitwise operators related advanced um, DSA questions. Or bitwise algorithms. Leak code. Yes. So see here. I haven't went through that Jashir. Jashir, can you share me the Kunal's DSS sheet here in the chat? Now itself I'll be telling you. Okay, see guys, so bit manipulation. Here everything will be making use of bit operators. So the reason for spending more time on the bitwise representation, what and all the manipulations that can be done with the bits of a particular number, it is because bit bit manipulation plays a key role whenever you are trying to solve very advanced problems. Like see here. In bitwise manipulation, 228 problems are there at LeetCode. You can try solving it, start from easy level and then to medium, and then hard will be a combination of easy as well as medium problems. Okay, so shortest path to get all keys here and all we'll be using bitwise operators only. So bit manipulation. Jashir, can you share me the Kunal's DSA sheet here? So guys, are you clear with today's class? So we have just seen the operators and we have also seen one of the question. Okay, and I'll be, just, I'll be making use of the collection framework hash map. Okay, don't worry. I'll be just showing you the code. Okay, because collection framework, if time permits, we'll be seeing that in our last session. So in order to make use of hash map, I want to declare it hash map integer. My key is going to be an integer data type as well as my value is also going to be an integer data type. So hash map integer comma integer, my hash map name is equal to new hash map. Okay, now I want to traverse the array. So for int in, it is a for each loop. Tomorrow you'll be seeing loop. I'll be having a default a predefined function if not map dot contains key I. Okay, I'll be putting map dot put I comma 1. Okay, so how it operates is once again. Yeah. So my map will be there. Okay, now my for loop will be coming. My for loop will be here. So I am going to traverse the elements in my array, right? So now my current element is 1. It checks if the key 1 is already present in the map. No, right? So that is this condition. If map dot contains key, if not map dot contains key, in the sense the map does not have 1 as the key. So what I'm going to put? I'm just going to put map dot put 1 and the value as 1. So key will be my 1 and my value will be 1. Okay. And next also what happens? Now 3 will be my element. Okay. Traversing the sense going through or accessing the elements in an array. So 3. I'm going to check in the if condition like whether 3 is available as a key in my map or not. So 3 is not there. So I'll be giving 3 and 1. Okay. And next condition, next my element will be 3. But now but now already 3 is present in my map. So duplication of keys is not possible. So in the else condition, what you have to give is, you have to first retrieve the value map dot get of I. If this condition fails, then it means that 3 key is already present over here, right? So you have to first get the value that is already present in the key 3. So in my value will be 1. Okay. I want to increment the value. So now my value becomes 2. Okay. And I want to again put the updated frequency value in my map. So I'll be putting the value which is present over here. Val is 2, right? So I'll be putting 3 as 2. Okay. Now again, my frequency will be, my element will be 5. 5 is not present in my map. So I am going to give 5 as 1. I'm going to put 5 as the key and 1 as the value. And again, 5 is already present. So I'm going to retrieve the value which is already present to the key corresponding to 5. 1 is my value. I'm going to increment it, val plus plus. I'm going to put it over here. So frequency of 5 is 2. And again, 1 is there. So I want to retrieve the value of 1. Already 1 is the value for the key 1. I'll be incrementing it and I'll be replacing here. Okay. And again, 3 is my case. Okay. I'm going to get the value of the key 3 because 3 is already present. So my value is 2. I'll be incrementing it. It becomes 3 and then I'll be updating my hash map. Again, similarly, 5 comes. I want to retrieve the value that is previously present 2. I want to increment. It becomes 3 and it gets updated. And again, last element, it is 5. 5 is already present in my map. I'll be retrieving the value. 3 is present over here. I'll be incrementing it and again I'll be replacing it in my hash map. So my hash map will be having this will be my hash map. So when I try to print my hash map, this is going to be my answer. Oh, here we are having 7 also, right? So frequency of 1 is 2, 3 is 4, 5 is 4, and 7 is 1. So this is one of the way to find the frequency with the help of hash map. Okay, clear? Okay. I'm talking about Kunal. Okay. Jashir, actually, I was packed up with not many work. So today I'll be checking the YouTube DSA playlist and then I'll be letting you know. Sorry, Jashir. Okay. Tomorrow I'll start the session by giving by telling about DSA playlist, but I am not that much expert in order to validate someone's work. But for sure, I'll be telling. Anyways, like everybody gives good content only, right? So I'll be telling if it's fine. If anything is needed to be added, you can refer the additional concepts in other channel or other materials as well. Okay. So guys, are you clear with today's concepts? What and all the concepts which you have seen today? Today we have dealt more on the bitwise operations because uh, I mean the proof of the importance of bit manipulation is here in front of you. Okay. So yeah, with this we'll this is for today's session. And people, I just want your feedbacks. Okay, Jashan. Feedbacks like how was today's session? Okay, and if any improvements is to be made from my side, because in further sessions I'll rectify it. And if you people have any doubts, you can let me know in the chat. I just want acknowledgement from you people. Whether have you understand today the concepts? Hash map and all, it comes under collection framework, okay? But in order to tell you of how to calculate the frequency of the elements, I have given you a demonstration on hash map as well. And Jashir, how was today's class? Tomorrow we'll be starting our session with conditional statements, okay? Conditional statements, and also we should complete Java arrays and strings as well. Okay. So how was today's session, guys? Feedback from your side. Within a couple of minutes we'll wind up. Tomorrow also we'll be seeing more concepts and DSA problems as well. uh More, we have two sessions, like we do have session on 14 and 15. So guys, come on, like if you have any doubts, to post it in the chat and let me know the feedback. Actually, yesterday was 9 out of 10. Okay. But today was 11 out of 10. Okay, cool. Okay. And yesterday also I have planned a lot many things, but that's fine. Like today, I think I have covered up yesterday's work also. So improving day by day. Yes, for sure. And tomorrow it will be more cool because you'll be learning more, DSA approaches. And thank you for the feedback, Jashir. Okay, guys. So if you have any doubts, to let me, let me know in the chat. If you have any feedbacks or if you want me to improve anywhere, like you can let me know in the chat, or else we'll wind up the session. And thank you for your patience and thank you for, cooperating well. And today I I guess no. I am very confident that today there was no deviations and disturbances. Okay, guys. Thank you. Let's see you tomorrow. Thank you. Bye, all. Have a nice day.